right, ladies and gentlemen. Good afternoon to you guys. I hope you guys are doing well. I'm just going to kind of remind you all here that we have your study guide here for test 2. It's up. And here you go. Okay, there's your study guide. And I'm going to do something here really quick. Well, it's also on my end here. I think I'll do. But what I'm going to do here today is we're gonna talk a little bit about a few subjects here. We're going to get out of the way that you'll see on your test. One of which is revisiting this thing. Okay, what do we call this last time you guys were here? Oh no, that one's the Greek letter what? Mu. Is that true? Okay, and mu was defined to be the sum of x times p of x. You're going to look at this for all the values x. So this was also called last time the what? The mean. Is that true? We worked in the mean. Okay, good. But if you guys do remember, I think I did mention this. We could check the notes. So this is the definition of the mean. But we also call this is also known as AKA the expected value. So it's the expected value for a distribution, which is even known as the expectation. So we want to know this is also the expectation, what to expect. Expected value, expectation, it's your mean, and it's your long run average. Okay, so you have this thing here. It's the sum, which means to what? It means to add. That column. So we did the mean last time as well. So if you guys remember that. Now, okay, so what I'm going to share with you guys is how to look at this in terms of the context of a distribution here. What does it mean to expect? But before I do that, I'm going to go over this idea here. Remember, part of our course here, we have some S supplement here. So I'm going to express you guys, going back to doing a little bit of beginning algebra during our S portion supplement. Do you guys remember having a raffle? What's the purpose of a raffle? Anybody ever get involved with a raffle in your life? Yeah, well, you say, well, raffles are used. You might say you were involved with a raffle and you won a prize. Is that true? But what I want to share with you guys is that idea of a raffle is really associated with this definition of expected value. Okay, so if I said to you now, what's the purpose of your raffle? What do you guys think your main purpose would be? Sometimes people say it's to have fun, and I'll say, no, not really. Okay, the purpose of a raffle is to generate what we call revenue. Okay? You're generating revenue. And you have this very, very important equation, okay? Because P is R minus C. You might say, what is R? R stands for what? R is revenue. C is cost. P is profit. So you have this thing called profit is revenue minus cost. Okay, a little bit of beginning algebra here for you guys. So you might even say, well, what in the world is revenue? That's the money coming how? That's the money coming in. And what is cost? Well, it's the money going out, okay? Remember, anytime you have a raffle, the main purpose is to generate revenue so that you can obtain a what? A profit here, okay? This is the essence of the definition of expected value. Okay, the essence of it. I'm going to share with you guys how it works, okay? And all right, so let's go back and think of the days when we had a raffle. So give you guys an example here, okay? Let's say you sell 2,000, let's say you sell 1,000 tickets at $2 per ticket. Okay, for a chance to win. Oh, let's say you're going to win an iPad. Okay, now I'm going to give the cost for the iPad. It's $1,200, okay? So I'm going to ask you guys here to wake up and warm up with beginning algebra. Determine the what? Profit. Okay, in this model here. So this is some S. Shouldn't take too long, ladies and gentlemen. Read it, write it down. Let's find out what is the profit in this situation, okay? So read it, write it down, give us the profit. Give you guys some time to do that here. All right, let's go through these particular details. So remember, we're going to look at the essence of a raffle, which is really what your expected value definition is going to be here. Okay, that mean definition I gave you guys last time. Revenue minus what? Cost. What's that going to give you? Profit. Okay, this is why raffles exist, right? So let's try to determine that. So what's your revenue? Do you guys want to know? What did you guys get for your revenue here? Okay, you said it was 2,000. Now, how do you guys know it's 2,000? Yeah, so that's $2,000. Is that right? Okay, now what's the cost? Yeah, it's the amount of the iPad. Is that true? Okay, good. That's pretty good, ladies and gentlemen. That's a beginning algebra equation here. Okay? So it costs you money just to make a what? Just to generate revenue so you have a profit. What is your profit going to equal now? Yeah, your profit's going to be what? $800. You guys agree with that? Is that easy peasy lemon squeezy? So $800 profit. So is that pretty good? Notice you had to have money to start to what? Make money. You ever hear that statement? You need money to make money? Yeah, this is an example of that. Now, let's ask you guys this question here. This is what we're going to get at, okay? What is the profit per ticket what? Sold. Now, this is an extremely important process, ladies and gentlemen. This is that unitization process. You say, what do you mean to unitize? Well, you take the profit and divide by how many tickets did you sell? You sold 1,000 tickets. Is that true? So if I unitize here, take that 800, divide by 1,000. Do you guys know what you end up getting? 800 divided by 1,000? Let's see. What do you get? I'm going to get out that calculator. This is going to be what? 0.8. And now this is money, ladies and gentlemen. So I'm going to write this to the nearest what? To the nearest tenths. Because this is money, and if you were to look at a receipt, what are you really looking at? This is like 80 cents. Is that true? 80 cents. So, ladies and gentlemen, 80 cents. So you might say to me, no, Mr. Judge, I just bought a what ticket, and here's that lottery ticket. It cost me $2. What do you mean there's a profit of 80 cents per ticket sold? Right? This is per ticket sold. Does anybody know what's going on? The answer is yes. It's 80 cents per ticket sold. So every time you sell a ticket, a $2 ticket, what you see is really 80 cents of that. That's your profit. That's what you get to keep. The rest went toward the prize, right? So every time you sell a ticket, that's the lottery ticket. Yes, it's $2. You're really seeing what? 80 cents. Now, this is an extremely important detail, ladies and gentlemen. This is the essence of the definition I gave you guys the last time we were here, this mean definition. Okay, we have something called an expected value for the distribution. This is the expected value definition as well. But I have to share with you guys how you use it in the context of a probability distribution. Okay? All right, so let's kind of demonstrate that to you guys. This is an important thing. This is a big deal. So if I said to you, okay, guess what? You're going to gamble here because that's what a lottery is. Is that true? Isn't it gambling? So if I said to you, what are the two outcomes associated with really any sort of gambling game? You guys know there's only two outcomes? Do you guys know that? Only two outcomes. What are they? You can either what? Win, or you can what? Lose. So if you gamble, you're either going to win or you're going to lose. Okay? So here's how you guys want to think about this. I'm going to write this down in a way that we seen yesterday. X is the outcome. P of X is your probability. Okay? So start with the problem this way here. Say, what do you mean? Go back. I'm going to try to assign a value to losing. Okay? I need a numerical value associated with losing here. And here's what you guys want to do, right? Let's say you buy this lottery ticket, right? You buy one of these lottery tickets. If you buy a lottery ticket, ladies and gentlemen, and you lose, how much money did you lose? $2. Good. So put -2 associated with the outcome of losing, okay? These are your outcomes. That's an outcome column. So yeah, you bought a lottery ticket for $2. Yes, you lost. And so, ladies and gentlemen, okay, you're out $2. Is that right? Okay. Lottery ticket. Okay. Now, let's associate a value now with winning. So that if you win, what do you go home and tell everybody? Nothing. Good. Let's say you won the iPad. You said, okay, I want an iPad, but how much is the iPad? $1,200. Is that right? You go home and you tell everybody, guess what? I want an iPad, and it was $1,200. I want an iPad, everybody. Or let's say it wasn't even an iPad. They gave you the check for $1,200. You go home and you tell everybody, guess what? I want $1,200. But you're actually wrong. Does anybody know why you're wrong? Why can't you really tell everybody that? That's really not true. You bought a $2 ticket, and yes, you won $1,200. They gave you a check for $1,200. Why can't you say to everybody that you won $1,200? Isn't that kind of a riddle? Sounds like a riddle, doesn't it? You can't tell everybody you won $1,200 because you didn't win $1,200. What'd you really win? 11 what? 98. Why is it 1198 and not 1200? Two of those dollars were what? Were yours to begin with. So two of those, so it is always the net. So always put the net value, ladies and gentlemen, the net value. You netted what? 1198. Now you say, what's the net? Well, you take out the total prize minus the cost, and that gave you the 1198. Okay, easy peasy lemon squeezy. Okay. Good. Okay, we're going to make this look like the distribution table. Now, go back to this list. We have to try to find the probability of winning here. The probability that you win. How could you find that probability? What's the probability you win here? What's that? Yes, absolutely. Why? Why is it one? Why is the probability of winning 1 out of 1,000?
They sold 1,000 tickets to 1,000 people, but you're one of those people.
Yeah, and there's only one prize, right? For a chance to win an iPad, there's only one prize. So there's one winning ticket out of what? 1,000 tickets. So that's the probability of winning here. Okay? All right, you guys okay with that? That's the chance you win. Good. Okay, now. What's the chance that you lose? What's the probability you lose, ladies and gentlemen? The probability you lose is the complement of what? Winning. Is that true? You've had homework on that. So, okay, let's find the probability of losing. So, this is going to be 1 minus 1 out of what? 1,000. We have to go back and do this arithmetic again, right? Do you guys remember how to do this? Isn't this going to be what? 1,000 out of 1,000? Okay, remember that little trick we've been doing? Same denominator now. 1,000 minus 1 out of what? 1,000. What's 1,000 minus 1? 999 out of what? 1,000. So we get here 999 out of what? 1,000. Okay, here we go. Now, what I'm going to say to you guys is this. Let's put the decimal representations here and see why. 1 out of 1,000. Here we go. What is that? Isn't that 0.001? 999 divided by what? 1,000. What are you guys going to get here? 0.999? Is that right? So I want you guys to take a really, really good look at this here. Because like we did last time, we need that x times p of x what? Column. We're going to use the definition. We're going to find the mean here. We're going to use that definition we learned last time. Because it's also known as the expected value as well. So let's try this out here. Okay, so you're going to see what it has to do with our raffle now. And so, okay, let's take those values. You might say, well, what are they? You need x times what? P of x. So, x, oops, wrong color. X times what? P of x. So over here, 1198 times 0.001, this is your what? This is your x value, and this is times your what? P of x value. X times P of x. Over here, you get what? Negative 2 times 0.999. So, ladies and gentlemen, here it is. You're going to get what? Negative 2 times what? 0.99. What are you going to do with these numbers? Bless you. What are you guys going to do with these? Do you guys know? What do you do with these numbers? You're going to add them. So, what you can do is you can write this here horizontally. Let me share with you guys that. That's going to be 1198 times 0.001 plus the negative 2 times 0.999. So double check so you guys can see this here. Okay, that sum I wrote here twice. I wrote it, oh what? Horizontal and vertical. And let's see what we get. Here we go. 1198 times point what? 001 plus a negative, that's negative 2 times that 0.999. So let's see, what is this going to give us? Did you guys see what number that is? Can you guys see that up close? That's what you enter in your calculator. Okay, so when you enter that in your calculator, we get this negative number, right? You get negative point what? 8, but I'm going to put it as negative 0.80. Same answer right here, negative 0.80 here. Okay, so whether you do it vertically or horizontally, it really doesn't matter. But my point I am making here to you all, okay, is that that's the same exact process we used earlier. This is known as an expected value or an expectation or a long run average, and it's negative. So this is a negative what? Expected value game, ladies and gentlemen. So every person who buys that lottery ticket, every person, you don't see that person as a person anymore. You see them as 80 cents. So they're giving you 80 cents every time you sell that ticket. They're just saying, here's 80 cents. That's what makes the world go round. Okay, let's ask you guys this question. Anybody go to Las Vegas? Who goes to Vegas? One person, maybe? What do you do in Vegas? Nothing. Okay, anybody else go to Vegas? You guys are probably too young. What do you do in Vegas?
Well, I'm barely 20, so I can't really go to casinos. I can walk there, but my parents usually do all the gambling.
Your parents do some gambling. Okay, so you've never seen it. All right.
Well, I have seen it, so walked with them.
Oh, you've walked with them. Okay.
Like since I was 11, every year we go for spring break.
Mm-hmm. Oh, really?
Yeah.
All right. So let's say you have a 25-cent slot machine. Now, yes, it costs 0.25, okay? What you don't know is it maybe has an expected value of negative, that's like a negative a dime. So you said you've seen the people, right? What have you seen? You've seen people just put in what? Money all the time. Is that right? Say, here's my quarter, here's my quarter, here's my quarter. Is that right?
Yeah.
You know what's really happening? If the negative expected value is what you see here, think of it this way. Every time somebody plays that machine, they're saying, here's my dime, here's my dime, here's my dime. Every game in Las Vegas is a negative expected value game. So that everybody is ultimately just doing what that you see in Vegas. They're just saying, take my money, take my money, take my money, take my what? Money. Every game in Vegas has a negative expected value. Just like this what? Just like this raffle we talked about. Just like the raffle, ladies and gentlemen. It's the same exact thing. So you're looking at the foundation behind it. You're looking at the mathematics behind it, which is a beginning algebra, question, a relationship. Profit is revenue minus cost that you just unitized. But it's now in the form of a distribution because you have X and P of X, and you're looking for the mean. It's the long run average. It's saying, okay, in the long run, what will we see? You see everybody contributing what? 80 cents. And then that's the deal. Wow, what do you guys think about that? Isn't that amazing? And then I keep saying to people, this is what makes the world go round. Okay? For example, does anybody have any life insurance? You might say, what is really life insurance? You guys know what life insurance is? It's a what? It's a gamble. You go, Mr. Judge, that's horrible. No. Life insurance works the same way. So does car insurance. Car insurance is a gamble. It works exactly the same way. Let me share with you guys how it works, right? Let's say a $38,000 life insurance policy for a 26-year-old male costs $850. Okay, now that's just for a what? That's just for a chance for the person to live 1 year, 27. It's an annual policy. If the probability that a 26-year-old male lives to see 27 years is 0.995. What's the expected what value? So this is the very, 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 very famous life insurance question, okay? Life insurance. That's how life insurance works. It's a gamble. So what you do is you buy a policy, ladies and gentlemen. And really, again, there's only two outcomes. What do you guys think the outcomes are? Only two. What could they be? You can either what? Live, or you can what? Well, we're going to say not live. How's that? Does that sound a little bit better? Let's not make everybody, let's not scare everybody today. It's not Halloween yet. Have you gotten your Halloween costume yet? You have? What are you going to be? Classified? All right. Anybody else get a Halloween costume yet?
I got one.
What are you going to be?
A butler.
A butler? Okay.
My niece is gonna be a princess, so I'm gonna be her butler.
So your niece is a princess, and you're the butler.
She's only 2, so.
Okay.
Making her happy.
Good. How old is your niece?
2.
2. Oh, good. Is she mean by any chance? No. Good. Because 2 is a pretty tough age. Okay, wow. Anybody else? You got your costume. What are you guys going to be? All right. What? You got a probability now, okay? So we're going to say here's going to be what? P of x, okay? You guys okay with that? I'm going to share with you guys how this is exactly the same as before. Okay? So let's think about this, okay? It's just like gambling. Well, this time I'm going to say start with living. You see, how does life insurance work? If you live in terms of the money, what happens with the money situation? You don't get any money, but don't forget what? Yeah, you paid $850 for that policy. So in other words, that $850 came out of your what? Pocket. You guys okay with that? So whatever the cost of the policy is, just for living, that money came out of your pocket. Now the good news is, if you do not live, what happens if you don't live? Well, if you don't live, yes, you still don't get your money. But your beneficiaries get your money. You say, what do you mean? Whoever you decide, I don't know, maybe you leave your money to your dog. Or maybe you leave it to your cat or to your mom or your dad or your husband or your wife or whoever. In other words, you think they're going to get a check for what? $38,000. Or you think you're going to get the check even though you're not. Think of it that way. You tell everybody, guess what? I didn't live. I got a check for $38,000. No, it must be net again. So take the $38,000, okay, and subtract your 800 and what? 50. What do you guys end up with? Do you guys know what you end up with? 37,100 and what? $50, ladies and gentlemen. This is what you get for not what? Living. And it's really, again, this always has to be what again? Net. So as you guys can see, it's kind of a little bit like gambling, don't you think? Don't you guys think it's kind of like gambling? Okay, what's the probability that you live, though? You need a probability value. Do you have one? Sure, the probability that the 26-year-old male lives to see 27, what is that going to be? 0.995. So that's a chance you live. What's the chance you do not live? How do you figure that part out? Do you guys remember? Use the complement rule, right? We studied these probabilities. The probability you do not live is 1 minus the probability you what? Live. 1 minus point what? 995. And so 1 minus 0.995, again, going to your calculator, is going to be 0.005. And that's a chance of not living. Okay, you guys okay with that? Now, this is going to be x times p of x, which means you get negative 850 times 0.995, which is also taking 37,150 times 0.005. Okay? You're going to add these values the same way you did before. So I'm just going to move some of this over because I want it to be clear. And I'm going to kind of write it a little bit differently this time, I guess. I'm going to say, well, let's put this portion in red here so you guys can see that product in red, and maybe this portion here in purple. Maybe that's a little bit clearer for you guys, okay? We're going to compute the expected value. That's the whole idea. So we can write it this way again and say, okay, here's mu. Which will be negative 850 times 0.995 plus 37,150 times that 0.005. So I guess that was in red here, plus what you get here in what? Purple. Okay, let's see what we get now. Negative 850 times point what? 995 plus 37,150 times point zero zero what? 5. Okay, it looks pretty good to me. What do you guys think? Is that okay? Right, maybe you got to scroll in closer, double check. Okay. All right, let's hit enter. What do you guys get now? What do you guys see here? What's this expected value going to be? Negative what? Is that negative 660? Okay, so ladies and gentlemen, this is money. This is just like a raffle. This is gambling. But what do you guys know here? Here is a picture of a what? 26-year-old male. And the insurance companies, instead of seeing that picture of a 26-year-old male, they see the money side. They see that person with this policy, they just see $660. They go, every time I sell a policy to a 26-year-old male, under these terms, they represent $660 for us. So you don't see, that's how they look at it. Oh, we can expect $660 to come to us. And that's why insurance companies have those big those big buildings and fancy computers, because everybody that buys their policies is really doing what? Just like Las Vegas, they're really giving you money. So every policy that they sell is bringing money to them. Even though you go, no, sometimes people die and they got to pay it out. Yes, that's true. Just like in Las Vegas, sometimes people win and they got to pay it out. But a lot more people lose and they bring in that revenue, a lot more of that revenue. This is the long run average, also known as a what? Expected value, ladies and gentlemen. It's what makes the world go round. So don't think the insurance companies are losing money, because they're not. They're what? Making money. Car insurance works the same way. Do you guys have car insurance? Maybe, maybe not. Car insurance works the same way. They're going to make money on every policy. They don't design the terms so that they lose money. They just don't. Why would they? They design the terms so they always have a negative what? Expected value. That mu will always be negative. Okay, you guys okay with that? Isn't that pretty interesting how that definition that I gave you guys makes the world go round? Yeah. Well, let's go back to gambling. What if I ask you guys? Let's have you guys try one of these here. How about this? What if I said to you guys now, I said, okay, let's say you're going to play the, you guys are going to play the Black King game. Okay? I'm going to say it costs $5 for a chance to win $50. Okay? So to win, you must select a what? A Black King. Compute the what? Expected value. Now, your expected value is always to the nearest hundredths. See what you get. Okay, here we go. You guys ready? Here's your outcome. What are your two outcomes? You're going to win or lose. Good job. So you're going to either what? Win, or you can what? Lose. Okay, you guys okay with that? Okay, so, put your x, put your p of x. You got this probability here for you. Okay. Now, go back. How do you start a gambling situation, right? How do you want to think of this? When you read this, what does it say? It says it costs what? $5 for a chance to win 50. Okay. So what does that mean? It means if you lose, how much money did you lose? Good, so put -5. Is that right? You guys okay with that? What if it costs $10 to play this game? What do you put? -10. What if it costs $1? -1. What if it costs $20? -20. Good. Now, let's say you win. Are you going to tell everybody you won $50? Say no. What do you get to tell everybody? You won what? $45. You won 45, or you what? Lost 5. Easy peasy lemon squeezy. Remember, it's always net. It is always the difference. Okay, so you might say, how did you get that? Well, it's the difference. Okay, it's what? 50 minus 5. What's the probability if you play this game? How do you win? You win by selecting a what? A black king. Is that true? Okay, how do you compute that probability of winning then? How many black kings are there in a standard deck? 2 outstanding. How many cards? Is that 52, ladies and gentlemen? Doesn't that reduce to 1 out of 26? Okay, so far so good? All right, that's the probability that you select a black king, probability that you win. So let's compute now the probability that you not win, which is actually what? Losing. Is that true? So we're going to use the complement rule. That's why we did our homework on the complement rule. Okay, so what's the probability that you win? 1 out of 26. We just found that. What's the mathematics you guys use again? Do you guys remember? The denominator is 26. So what do you guys do? You're going to replace this what? Numerator, this 1 by 26 over 26. So we discussed how to do that. That's 26 minus 1 out of what? 26. What does this equal? Isn't that 25 out of 26? Isn't that the same as the definition? So the probability that you lose is 25 out of what? 26, ladies and gentlemen. Okay. Easy peasy lemon squeezy. Okay, so now we have x and we have p of x. And then now you might say, okay, what are you going to do? You're going to take that x value. Every x value gets multiplied here. So this is 45 times 1 over 26. This is -5, okay, times 25 out of what? 26. So you might say, am I supposed to add these? Yes. So let's write down this mu here. Mu equals, what is that? 45, ladies and gentlemen, times the 1 out of 26 plus negative 5 times what? 25 out of 26. Okay, so we can add this vertically, or we can add it how? Horizontally. Either way, add it vertically or add it horizontally. So I want to maybe colorize this here for you guys to see everything. 45 times 1 over 26. Negative 5 times 25 out of 26, okay? And I did it again. I just said here. 45 times 1 out of 26 and negative 5 times 25 out of 26. This is addition again. Okay. All right, ladies and gentlemen. Now we're going to do a little bit of that S. You say, what is this? What does this supplement mean? What do you mean S? Does anybody remember, how do you take a whole number and multiply it with a fraction? Let's do some arithmetic here. Whole number times a fraction. What do you guys think? Anybody remember what you do? How do you do that? Yeah, you put the whole number over 1, and now what you're really doing is multiplying what? 2 fractions. How do you multiply fractions? Right? This is called horizontal across. So you take the A times B, you leave it in the numerator. You take the 1 times C, you leave it in the denominator. Well, 1 times anything is itself. So ladies and gentlemen, this is like an algorithm. It's an algorithm for arithmetic. So now you have mu going to be what? 45 times 1 out of 26 plus negative 5 times 25 out of 26, right? You're doing a little bit of some what? A little bit of arithmetic, ladies and gentlemen. You're going to do some arithmetic here. Now, you might say, I don't know what 45 times 1 is 45. Is that right? And then what's 5 times 25? That's negative 5. Let's do some S. What's a negative times a positive? Do you guys remember? Isn't that negative? I'm going to put our S over here in purple. So what's 5 times 25? That's 100 and what? 25. So it's 125 divided by 26. So you have this what? These denominators. Let's see what you end up with. Mu will be 45 plus a negative 125. Everything out of what? That denominator 26. What's the algorithm? Oh, A over C plus what? B over C. Isn't that A plus B over C? Okay, so this is going to give us our answer. Now we can enter this in the calculator this way here. Okay, we can enter it in the calculator. Let's see what that looks like. Parentheses, 45, okay. I'm going to scroll out because I'm going to do addition of a negative. I want you guys to see addition of a negative 125. Close that. Divide by 26. What do you guys end up with? Right? Approximate this to the nearest what? If this is money, which it is, what do you see as a receipt? Only 2 decimal places? So negative 0 what? Negative 0.8. So, ladies and gentlemen, you're going to owe how much? Not owe, I should say this is another what? Negative expected value game. So, every person that plays this Black King game is going to lose how much money? $3.08. Again, every game in Las Vegas is a negative expected value game. Every game. Even this game called the Black what? Black King game. What do you guys think? Is that pretty interesting? Yeah. Well, you mean write it as a decimal?
Yeah.
No. But you still will get the same answer.
No, you get negative
Negative
$3, or I got
$3 and how much?
0 cents. So -$3.
Well, be careful here. You have a very good question. The question is this. Some people are going to say, Mr. Judge, I want to put decimals. Okay. Well, I mean, you could do that, but let's take a look at 1 over 26, okay? Let me give you guys a little bit of some information here. 1 divided by 26 is really what? It's 0.03 what? It depends on where you approximate, right? Well, again, oh yeah, if you put 0.4, number one, be careful. Did you put 0.4 or 0. Or did you put, if 0.4 is 40 cents. This is 0.038. Okay, if you put 0.04, you approximated to the tenths. So you have to be careful. Because as you guys can see, this fraction has a lot more decimals. So if you're going to say to me, I want to go the decimal route, you certainly can. I might say go to the nearest 10,000ths position. Like a 0.038 what? 5. Okay? The nearest 10,000ths position as that decimal. Be more accurate. 25 out of 26, so the nearest 10,000ths again. Go to the 10,000ths. That's going to be 0.9 what? 615, okay? So here's what I'm saying. Be more accurate. If you did that, you're going to get a more accurate what? Answer. You're going to get that $3 and what? 8 cents, not $3. So remember, you say, well, why do I want to be more accurate? Because this is money, ladies and gentlemen. People want to what? Be accurate to money values here. You want to be accurate to the penny, which means you go to a few more decimal places just to cover your accuracy. So if you're very crude in your approximation, you're going to get a very crude estimate at the end. And you want it more accurate. So all I would recommend, if you're going to do the decimals, you're fine, but just be more accurate. Don't go to the nearest, go out to 4 decimal places. Yes?
I stopped at the 45 times 1 over 26, and I got the same answer as the negative 3.076 as we kept going.
Yeah.
So what do you think about that?
Negative 3.076. Well, make your final answer to the hundredths. Now you say, why is that final answer here's here's the remark. Right? You see that? Why would I want my final answer to be to the nearest hundredths? Because this is money. Money is to the nearest tenths. I'm sorry, nearest hundredths. So this is approximately negative what? 3.08. Because this is down to the penny. So whatever you see on a receipt is always down to the what? Penny. Do you guys notice that? You ever look at your receipts? Always to the penny. It's not to, that's the hundredths position. That's not the thousands, that's the hundredths. It's 2 decimal places, So I just want to give you guys that information because expected value for the gambling is always money. It's money, money, money. It's what makes the world go what? Round. Okay, you guys see what I'm saying? Money makes the world go round. Okay, we're gonna give you guys another example. Okay, I'm gonna go out to the last class because they did expected value already. Okay, I'm going to do this here. I'm going to copy that. And did I share with you guys a roulette wheel? Do you guys know how to play roulette? Huh? Do you guys like James Bond? Doesn't James Bond play roulette? You go, I don't know. Take a look at this wheel. You know what happens is you spin this wheel. This is how you gamble. You spin this wheel and a ball bounces all over the place and lands on something. It stops. Now, notice what this looks like. You got the green numbers. What are the green numbers? 0 and what? 00. So those numbers are green. I'm going to put the sample space over here, okay? So I just want to kind of share that. 0, 00. This is the sample space. And then you got the numbers 1 to 36. Is that true? All right, you guys okay with that? 1 to 36. Okay. Some of those numbers are red, some of those are black, some of those are green. So if I ask you guys this question here, okay, we're going to create a game, a gambling game, an expected value game. But with what? With roulette. So I'm going to say to you guys, it costs $10 for a chance to win $250. Okay? You win by landing on green. Let's change this. Let's say you win $100. I apologize. And you win by landing on green, okay? Compute the what? Expected value. So let's try this game out. We're going to have some fun. We're going to try this game. Okay, you guys ready to try it out? It's pretty simple. You guys having fun yet? You guys learning about reality called the expected value, right? What are the outcomes when you gamble? You can win or you can what? Lose. So put the X column here for your outcomes. You win or you what? You lose. Is that true? Okay. So look at the money. Look at this situation. It costs $10 for a chance to win 100. So if you play this game and you what? Lose. How much money do you lose by playing this game? Good. So put -10. You guys okay with that? That's pretty good. Okay. Now, isn't this all the same way? Okay, what about winning? What is your net? Don't tell everybody you won $100 if you won. Tell them you won what? Because it is always what? Net. That 100 minus what? 10. Okay, you guys okay with that? You netted this when you what? When you win. Take a look. Take that difference. 100 minus 10 is 90, okay? What if you won 250? Well, 250 minus 10 will be you netted 240, remember? Now, let's go to the probability questions. Let's see. How do you win this game? You have to land on what? On green. Is that true? Okay. I picked green because it stands out. So, how many numbers are green? How many numbers are in this sample space? Be careful. 38 numbers. Yeah, that's 36 plus the 2. Yeah, there you go. See that? You could do this. Is it 38 numbers? What does that reduce to as a fraction? Okay, 1 out of 19. You guys get good with that? You guys see my point? You guys can do this. That's the probability that you win. So you say 1 out of 19, and maybe you said, Mr. Judge, I'm going to do this like the life insurance, like you just talked about, but I'm going to be careful. I'm going to be careful because I learned from the last example we got to be careful with our decimals. Is that true? So we can do it that way. It's kind of crude. I would use fractions personally, but you can do this. Let's go out to 4 decimal places. What are we going to get? Point what? 0.526. Okay, you with me on that one? All right. And so this is going to be, either answer would be fine. You can say, can I use the fraction or can I use this decimal? And it went out to 4 decimal places. Okay. Now, what's the probability that you lose? Do you guys know that probability? It's 18 out of 19. Is that true? Shall we do the math? Probability that you lose. 1 minus the probability that you win. 1 minus that 1 out of 19. Shall we do the fraction work again? Denominator's 19. Replace this here with what? 19 out of 19. And what do you end up with? 19 minus 1 out of 19. What's that going to give you? Is that 18 out of 19? Sure enough it is. Is that right? Okay, but you might say, I want to use the decimal again. Okay. Then put 18 divided by 19. So what is that to the nearest what? 0.947. What happens? 947 what? 4. And what color are we going to give this here? Red. Easy peasy lemon squeezy. $90 times 0.0526. Negative 10 times 0.9474. So, ladies and gentlemen, this is what you guys see here. Okay? Double check. Does that look okay to you guys? Does that look pretty good? If I keep all the colors the same here? Okay. Now, let's put this in terms of mu down here. Remember, what you would really do is add these, okay? So if you want, if you guys realize, hey, I've seen that over and over, Mr. Judge, I know what you're going to do. Okay, let's just do it this way here. Use that definition of expected value or the mean. We're just going to add the x, p of x column, okay? What does that look like in the TI? Here's what it looks like. 90 times, I think I'll scroll out so you see everything. Okay, 90 times 0.0526 plus the negative 10 times point what? 9474. And you get negative 4 point what? 74. And what does that mean? What does that mean? It means the expected value is negative $4 and what? 74 cents. Again, so you guys know, everybody that plays this game loses what? $4 and what? 74 cents. Easy peasy lemon squeezy. And this is the roulette wheel, ladies and gentlemen. This is playing roulette. Now, I just want you to say something to you guys here, just so you guys know. Landing on green. Landing on green, by the way, isn't that the same as landing on 0 or 00? Isn't that landing on green? What do I mean by that? The probability of landing on green, I could have done this, is 0 or what? 00. Do you guys have the addition rule? Okay, remember the addition rule? Minus both? Well, it's impossible to land on what? Both 0 and 00. Is that true? So that means the probability of landing on 0 is 1 out of 36, plus the probability of landing on 00 is another 1 out of 36, which gives you what? 2 out of 36, which is the same, sorry, screwed up. It's not 36, it's 30 what? 38. That's 2 out of 38, which is exactly the same as what we did earlier. I just want to share with you guys that this is really an OR question, or can be thought of also as a what? OR question, because that's what it means to land on what? On the green. Just going to share that with you guys. Okay, let's give you guys a break. What do you guys think? Should we give you a break? I think you earned it. Did you guys earn a break? Okay. You're going to go to McDonald's? What are you going to go do? Starbucks? Chipotle? What are you going to order at Chipotle? What's good at Chipotle, ladies and gentlemen?
Never been there.
You never been there? Really? Anybody here go to Chipotle? What's good? The which one? Mmm. Is it good? Anybody else? What do you guys order? Nothing? Do they have a carne asada there? Do they have asada at Chipotle? They had it for a while? Was that any good? Anyway, okay. Well, I ordered the barbacoa. I like shredded beef. Is that any good? I like it. I like shredded beef. Anyway. Okay. Take a break. We'll be right back.